Okay, this is Dr. Williamson. I'm going to solve some of these problems, just a few, not all of them. I've got a few minutes before I have to go teach a lab. But let's look at problem number 17, for example. Okay, and it says, which formulas represent ionic compounds and which represent covalent compounds? Okay, well, when we go over to the periodic table and we look at the heavy stair-step line that separates the metals from the non-metals, and we look at CO2, we see that that is carbon connected with oxygen. CO2, you guys may not know this yet, but it's carbon connected with oxygen. Non-metal connected to non-metal, those are covalent compounds. Okay, I want to show you that. Let's look at, I'm not going to do all of these. Let's look at KF. That is potassium connected to fluoride. That is a metal with a non-metal. That is an ionic compound. Okay, it's an ionic compound. That's how you tell the difference. We do CH5N. These are carbon. Let me kind of erase this stuff here. Do CH5N, carbon and nitrogen are nonmetals. Hydrogen over here is on the metal side, but it is still a nonmetal. So these are all covalent compounds. They're all covalent compounds. Okay, so let's do some others, right? Let's see, number 19, potassium and oxygen. Which pairs of elements are likely to form ionic and which are likely to form covalent? Potassium here, oxygen over here, metal with a non-metal. That's likely to form ionic compounds. How about sulfur and carbon? That is sulfur and carbon, two nonmetals. That's likely to form covalent compounds. All right. Now let's take a look at number 34. Let me erase some of this stuff and kind of clean it up. All right. Let's take a look at number, what did I say, 34? I meant 24. How many protons and electrons are present in each ion? Let's look at potassium. Here's potassium. With a 19, that means there are 19 protons. And if it was neutral potassium, that would mean there are 19 electrons, and it would have 0 charge. The only way potassium could have a +1 charge to become an ion is if it lost an electron. When I have 19 protons and 18 electrons, I end up with a net +1 charge, and that gives me my potassium ion. Remember, electrons are negatively charged. I can't change the number of protons because then I would no longer have potassium. Okay, let's take a look at Fe2+. Let's kind of erase this. All right, erase. Let's take a look at Fe2+. Here's iron. If it was neutral iron with a 0 charge, that would mean it has 26 protons. Iron is the atom that has 26 protons. And if it's neutral, that means it has 26 electrons and it has a 0 charge. I'm putting a line through it so we know I'm not writing oxygen, it's a 0. The only way iron can become a +2 charge is if we change the number of electrons. And I have to change the number of electrons such that I have a net +2 charge. If I lose 2 electrons to somewhere else, I'll end up with a +2 charge. So I have 26 pluses, 24 minuses, and that'll give me the iron +2 ion. That's how that works. Okay, guys? Let's do one more. We did, let's see here, we did sum of 17, sum of 19, sum of 24. Let's do sum of 25. I'll just do one of them. Identify each atom or ion. And I'm going to do B. 15 protons. Okay. If it's got 15 protons, that is going to be phosphorus. P with 15 protons. Phosphorus. 16 neutrons. And 0. And 18 electrons. I know that the net charge, never mind the neutrons, the net charge is going to be -3. Because when I look at the protons, they're supposed to be let's say, oh, come on. I forgot to put the letter P there for P+. Protons, right? When I look at the protons and the electrons, that's a -3 charge. So this is phosphorus, -3. And this happens to be, let's see, phosphorus, 15 plus 16. 15 plus 16 is 31. This is phosphorus. A particular isotope of phosphorus is phosphorus 31. You guys kind of remember that from chapter 1. It's phosphorus 31, and it has a -3 charge. Phosphorus 31, that's the isotope, and has a -3 charge. Okay, so that's number 17, 19, 24, 17, 19, 24, and 25. I'll see if I can do some more later, guys, but that's kind of enough for now. All right, okay then.